Welcome viewers, in this video we will see the properties of set operation, one of the topic available in sets, relation and function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic property of set operation. First one is commutative. In that two division available. First division A union B equal to B union A, right? A union B, if you take, that is equal to B union A also. Similarly, A intersect B is equal to B intersect A. So both are equal. Then associative, A union B of union C. A union B of union C equal to A union of B union C. Right? Here A and B is combined together. Here B and C is combined together. Both are equal. A union B of union C equal to A union of B union C. Similarly, A intersect B of intersect C equal to A intersect of B intersect C. Right? Here AB combined, here BC combined. Right? So both the terms are equal. If you A intersect B, that is intersect C is equal to A intersect, that is intersect with B intersect C also. Both are equal. Then distributive. Next one is the distributive property. A union of B intersect C. So previously we have only all are union. Here all are intersect. Here both are combined. A union of B intersect C equal to A union B intersect A union C, right? So that is written like that. A union B intersect A union C. That is the distributive, first distributive property. A intersect of B union C is equal to A intersect B union A intersect C. That is A intersect B union A intersect C, right? The A is first combined with B and A is combined with C with intersect. In between we have union. So that is called a distributive law. Next one is the identity. The next property is identity. A union null equal to A, right? If set A union null set means not having any element. So the set A is combined with null set means it will give A only. A intersect U null set equal to A only, right? Then idempotent, that is A union A equal to A. While combining A with A, it will give A only. A intersect A also A, right? Both are equal. Then absorption, A union of A intersect B equal to A, right? While A union A intersect B, we will get only again A only. Similarly, A intersect of A union B, that will give also A only. So this property we can use while solving the problem. A union B intersect B will give A only. A intersect A union B also will give A only. Then we have De Morgan's theorem. The important thing is we have the De Morgan's theorem. A union B dash equal to A dash intersect B dash. Important thing is here union means here intersect. Here dash available, entirely dash available, here individually dash available. A minus B union C is equal to A minus B intersect A minus C. Right? You can write that A minus B you intersect A minus C. Right? Not like a normal subtraction. A minus B. Then A minus C. Here union means here intersect. A intersect B dash equal to A dash union B dash. Right? Here intersect means here union. The dash available entirely, here dash available individually. Similarly, A minus B intersect C. Here union is there, here intersect. What is that? A minus B. Here intersect means union. Then A minus C. Right? So A minus B union A minus C. Right? So the important thing here union means intersect. Here union means intersect. Here intersect means union. Here intersect means union. Right? Like that you can remember. On symmetric difference, A symmetric difference of B is equal to B symmetric difference of A, right? So both are equal. A symmetric difference of B of symmetric difference of C equal to A symmetric difference of B symmetric difference C. Here A and B combined, here B and C combined, both are equal. A intersect B symmetric C can be written as A intersect B symmetric difference of A intersect C. Very simple. A and B is combined here, and A and C is combined here, symmetric difference. Here intersect means here also intersect. So A intersect B, A intersect C with symmetric difference. That is the important formula. We'll go for some more properties. The next one is on empty set and universal set. Pi dash equal to U. Similarly, U dash equal to pi. This is the pi means empty set. Pi dash means universal set. That is equal to U. U means universal set, but U dash is the empty set. That is equal to pi. Very simple. A union A dash equal to U. A means the set. A dash means other than set. So while combining both, we will get universal set. Then A intersect A dash equal to pi. A is the set. A dash means nothing. The other than A dash, other than A. So while combining two, we will get pi only, null set. A union universal set equal to U. A intersect universal set equal to A. Right? So the U means universal set. Pi means null set. Right? So pi is the null set. While taking pi dash, automatically we will get universal set. U is universal set containing all the elements. U dash means nothing. Pi is null set. So the set A is A union A dash. A means the elements in the A. A dash means other than the elements. So while combining both, we will get all the universal elements. A intersect A dash means nothing will be there. The A is the set of elements. A dash means other than A. So the common, there is no common. So null set. A union universal set. So universal set contain all the elements. So automatically the result will be universal set. A intersect universal element is a A. Universal set contain all the elements. A contain the elements of A. So the common is A only. Right. Next one is the on cardinality. Cardinality, the next property. We'll see that. The first one, for any two finite sets A and B, we can write n of A union B equal to n of A plus n of B minus n of A intersect B. So this will give the number of elements. These three will give the number of elements. Number of elements in A union B means A number of n of A plus n of B minus n of A intersect B. If A and B are disjoint finite set, then this is a finite set. This is a disjoint finite set. A union B equal to n of A union B equal to n of A plus n of B. Finite set means we are subtracting. For disjoint, we are not subtracting. N of A plus n of B. For any three finite set, A, B, C. So these two are two set. This is a three set. N of A union B union C equal to n of A plus n of B plus n of C minus n of A intersect B minus n of A intersect C minus A intersect n of B intersect C plus n of A intersect B intersect C. Right? So first the n of A, B, C is available. Then subtract the intersect AB, AC, BC. Then add intersect of ABC. So this is the related to the three sets. Right? So in this video we discuss about the properties available in the set that can be used for solving the problem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.